Thanks, Kelsey, and good morning, everyone. So in this talk, I'm attempting to give a brief overview of our existing ACCESS CMIP6 configurations and some initial thinking on where we might want to go in terms of future configurations. I probably can go through this relatively quickly. You probably have heard this all before. I'll start with the ACCESS ESM1.5, which is our Earth system model configuration. It's based on an older atmospheric component, UM7.3, at N96 resolution, horizontal resolution, roughly 1.9 by 1.3 degrees at 38 vertical levels. It uses an older aerosol scheme called Classic. It uses MOM5 as its ocean model, size 4.1 for the sea ice component, and it uses the OASIS MCT coupler. For the land, we're using cable, version 2.4, including its biogeochemistry components, CASA CMP for the land. For the ocean biogeochemistry, that's represented through Wombat. And we are also using a very simple land use change scheme, which has its limitations, and Ian will talk a little bit more about this in his talk. I listed the equilibrium climate sensitivity here, 3.9 Kelvin, because it's been talked about a lot. ENSO frequency is roughly 3 years. Because of the computational, low to medium computational requirements, we could run large ensembles with the ACCESS ESM in the order of 40 for historical and a large number of future scenarios as well, including extensions. It's set up on 384 cores, and we get about 16 simulation years per day. And the resource usage is about 1 kilo service unit per year. ACCESS CM2 is our climate model configuration. It uses the UM at version 10.6. It runs at the same horizontal resolution, but has a higher vertical resolution, 85 levels instead of the 38 that we use in the ESM. It also uses a newer aerosol scheme, GLOWMAP. MOM5, it's the same version as in the ESM. Sea ice, size 5.12, the OASIS MCT coupler. We're also using cable as the land surface model, but only the physical component. So there is no carbon cycle, and there's also no land use or land cover change. So we're using the same vegetation map all the way through from 1850 to 2300. Climate sensitivity listed here is 4.7 Kelvin, and so roughly biannual. That's just the frequency. Because the computational requirements are a lot higher for this model, the ensemble size is a lot smaller, so in the order of 5 to 10 for historical SSPs. It's set up on about 1,000 cores, and we get roughly 5 simulation years per day. And then we have ACCESS OM2. It doesn't have an atmospheric component, so the atmosphere is prescribed. Ocean model, MOM5.1. Same sea ice component, size 5.12, and the OASIS MCT coupler. It exists in 3 different configurations in terms of resolution. So we have a 1 degree configuration, a 1/4 degree, and a 10th degree. And the 10th degree also has a higher vertical resolution, 75 levels. In terms of compute, the 1 degree resolution uses 240 cores, and we get about 60, I hope these numbers are right, 60 simulation years per day. The 1/4 degree version, roughly 1,800 cores with 9 simulation years per day. And the 10th degree version, more than 6,000 cores and roughly 1 simulation year per day.
Yeah, a bit updated actually. You could double all those core counts in half.
Okay, so that's based on the paper, but yeah.
And how many cores on Guardian?
So yeah, we could take over Guardian with just our simulations. Whoops, something disappeared here. So what I'm trying to do here is, based on our existing configuration, to list possible other configuration options. I again start with the ESM1.5. We know when we put the ESM1.5 together for CMIP6, there will be limited opportunities in terms of future development for various reasons. So on the right column, on the left column, you see the current configuration, and then going from left to right, you see possible future configurations, and the changes are highlighted in green. So we can think about an ESM with a quarter-degree ocean. There are various advantages in doing so, improvements to the carbon cycle. We're also putting cable 3 into ACCESS-ESM, which we could then call ACCESS-ESM1.6 or whatever. There are good reasons for doing that, although we might not further develop ACCESS-ESM1.5 in general. It's our only existing Earth system model configuration that we have, working Earth system model configuration that we have. So it's a test platform for any incremental change that we do either on the land or the ocean side. So putting cable 3 in there then enables us to test new science or additional processes based on cable 3 that will be implemented in cable 3, and we can test that in an Earth system model framework. And that could then potentially be applied to other configuration options as well that use cable 3. So in terms of the naming convention, the L stands for low, the M stands for medium. The first letter refers to the atmosphere resolution and the second one to the ocean. So an ACCESS ESM1X minus LM, low resolution atmosphere, which is our existing resolution that we run in 96, and medium for the ocean refers to the quarter-degree ocean model. We could also think about a fast version, and by fast I mean faster than the 15 or 16 years per day that we get, so probably about 50. Whether or not that's achievable, I don't know, but we probably have to go to a very coarse resolution in the atmosphere, and then is the question, do we still get a physical performance that is acceptable? We have no experience with that. Some things to consider here. I listed some opportunities and risks. So we are developing from an existing code base, which means we can make incremental steps, we can do incremental science advances, and we can release that in a timely manner to the community as well. I already highlighted the kind of fast performance of the model, 16 simulation years per day. It's not really fast, but it's a lot faster than what we get with CM2 at the moment, and the climate sensitivity. Some of the risks, I already mentioned that it's not really future-proof. It uses an old version of the atmosphere. There is a disconnect from the climate community due to that. Our land use change scheme needs a lot of work. It's a very basic scheme that doesn't consider secondary vegetation or managed forests, which is a big issue. Precipitation over Australia has been highlighted. I think that could be an opportunity or a risk. It's one of the driest models in CMIP6. And we really need to understand why that is. Similar slide for CM2. So on the left column, you have the current configuration for CMIP6, and then going from left to right, possible configuration options, and the changes are highlighted in green. By putting cable 3 into CM2 and switching on the carbon cycle, that would give us an ESM2. And then with all the other configuration options, I don't distinguish anymore between a climate model or an Earth system model. You always get the climate model by switching off the carbon cycle. And with the carbon cycle, you have the Earth system model version. So we can think about a chemistry version. We can think about an ESM or CM2 with a medium resolution ocean. We can think about an ESM or CM2 with a higher resolution, medium resolution atmosphere and medium resolution ocean, and also about an ESM fast. But again, we have no experience with that, and by fast, we really need to get a fast model if we make compromises in terms of resolution on the atmosphere side. Okay, I have to be really quick now. So The same table again, highlighting some opportunities and risks. Same as with the ESM, we have an existing code base or platform to drive the development. So incremental steps are possible, incremental science advances, and a timely release to the community. The overall performance of CM2 is good. It has been selected for downscaling, but there are also some risks. I mean, even in the current low resolution configuration, we only get about 5 simulation years per day. I don't know what that means if we go to medium resolution in the atmosphere, 1-2 simulation years per day. Going back to Martin's talk from yesterday, the long spin up and the issues that you potentially have and the testing that you need to do, that's challenging. Biennial ENSO, climate sensitivity, 4.7 Kelvin. And then in terms of an ESM2, the carbon cycle is still untested. We haven't actually run CM2 with the carbon cycle switched on yet. So where could we go in the future in terms of new components? On the left-hand column, I call this an ESM3, but we can agree or disagree on that, how we go forward with the naming convention. That would use a newer atmospheric component, so the UM13.6 and an atmosphere land configuration 9. And then we can think about what I call here an ESM3+, and that would basically replace all existing components with either a new component or a different component in case of the coupler. And then you have the same options in terms of low resolution, medium, and fast with those configurations as well. We can also think about a higher resolution option, 10th degree ocean, or higher resolution atmosphere, or intermediate resolution for the atmosphere, something between N96 and N216. That's my last slide. So far, we've only talked about updating components or changing resolution options. We haven't really talked about the science yet. So this slide just lists a couple of options for the land on the left-hand side. So we're currently thinking about an improved land use change scheme, dynamic vegetation and fire. And again, Ian will talk about this in more detail. There are other things, other science components that have been developed by the Australian community that are either not in cable yet or are in a cable offline version, and where we might want to consider that there is value to get this into ACCESS as well. I listed some of them here, including improvements around our biogeochemistry scheme, CASA CNP. For the ocean and wombat, we might consider additional nutrients, extra phytoplankton classes, inclusion of coastal processes, and other options for the physical ocean. On the atmosphere chemistry side, our colleagues at the Bureau, they are testing a new convection scheme called COMORPH and how that performs in the and might improve things for the Australian region or other regions of interest. And then our contributions to GLOMAP and UKCA as well. And I will stop here. And hopefully that sets a bit the scene as well for the breakout sessions later.
Great. Thank you, Tilo.